All right, welcome back, guys. Today we're going to be working on lesson 9.2.2. How can I cover the course? We're talking about composite and decomposition, meaning building and breaking down percentages. So if you read along the introduction with me, can you imagine swimming, biking, running for of 140 miles without stopping? What about directing a team of dogs as they will set all the way across the state of Alaska? Athletes accomplish these feats each year in the Ironman Triathlon and the Iditarod Dog Sled Race. In this lesson, you work with your team and use your knowledge of percents to analyze portions of these amazing races. So first problem, question 40. Is training for the Ironman Triathlon, a 140-mile race that starts with swimming, continues with biking, and ends with running. The swimming portion is 1.5% of the race. The biking portion is 80% of the race. And the running is 18.5% of the race. So if you imagine adding up your percentages, the 1.5%, the 80%, and the 18.5% gives you 100%. That's the 100% the total of the race. And it's broken down or decomposed into three parts: swimming, biking, and running. So your task is to work with your team to help determine the approximate length of each segment of the race, making sure to show you. So Ms. and I see how you guys came up with how much of the race is swimming, how much it is biking, and how much of it is running. Okay, and all three of those should give you your 140 miles. So we want to think about these three questions. What tool will help us find the parts? What is the whole? And how can we get a distance of 10% of the race, or 1% of the race, or any of the denominations of that they give to us? So then pause the video, take a little bit of time to talk about what portion is swimming, biking, and running. We'll come back and talk you through these points and let you guys check your work as well. All right, so our basic equation that we can write is that biking plus running plus swimming gives us our total of 140 miles. So if you see these three arrows, we broke these down, decomposed them into biking was 80% of our total, running was 18.5% of our total, and swimming makes up 1.5% of our total. So 80%, we know we can write it several different ways. We can write it as 80 out of 100, or we can write it as 8 tenths, or 80 hundredths, as a decimal. Remember, the word of always means multiplication. And we know the total is 140 miles. So we can find 80% of our total simply by rewriting it as a fraction or decimal and multiplying it by our total. So 80% of 140 would give us
112 miles.
112 miles. So in this triathlon, we bike 112 miles. If we want to know what 18.5% of our total is, again, we can write it as 18.5 out of 100, because 18.5 per 100. Or we can write a decimal, 0.185. And multiply those by our total again of our total is times 140. And those would both give us
25 and 9 tenths.
So that means we biked for 112 miles, we ran for 25 and 9 tenths of miles. So our last part of this triathlon is swimming. So 1.5% is 1.5 out of 100. Or again, as a decimal, it is 0.015. And we multiply that of the total, multiply by our total of 140 miles. So if we multiply that by 140, we should get
2.1 miles.
2 1/10 miles. So now we have the number of miles biking, the number of miles we ran, and the number of miles we swam. If we add all three of those up, do we get our total of 140 miles? And the answer should be yes, it is. So going back to our question, our task was to determine the approximate length of each of the race during our work. So Ms. Lanz and I walked you through how to write equation and how to solve that to find our answer of the percentage of these three parts of the race. Question 42. So we're going to skip question 41. So 42 says, Ruby learned about the Ironman Triathlon. She decided to create her own race with several different parts. She said that the skateboard portion of it would be 25 hundredths of a mile. There would also be a tricycle portion, and another part of the race would be a 1 mile run. Letter A, if the skateboard section is exactly 10% of the race, how long is the race? Letter B, if the tricycle section is 4/10 of a mile, what percentage of the race is it? So pause the video. We gotta find out how long the race is and what percentage of the race the tricycle section is. Alright, so question A says if the skateboard section is exactly 10% of the race. So that's really important. When you see the word of, I like to highlight 10% of the race. How long is the total race? Meaning we don't know how long the race is, which means we can use a variable. So if we go over here, so we know this race is going to be composed of the skateboarding plus the tricycle plus the run. And we're focusing right now on just the skateboarding section of that. We know the skateboard section is 10% of the total, and 10% of the total is 25/100ths of a mile. Okay? So again, we don't know what the total is yet, so we use a variable for that. And we know that of means multiplication. So 10% can be written again as a decimal or a fraction. So 10% is just 10/100ths as a decimal. We multiply it by the total, and again, we don't know what the total is, so we use a variable. But we do know that 10% of the total is equal to 25/100ths. So we've been working on how to solve variables. So if I want this variable by itself, the total, I have to get rid of this 10/100ths that I'm multiplying by. So what is the inverse of multiplying by 10/100ths? Would be to divide both sides by 10/100ths. This leaves us with t. The total is 25/100ths divided by 10/100ths, which gives us 2.5 miles. So we now know for future questions that our skateboarding plus the tricycle plus the run is actually 2.5 miles. And we're going to use that information then in part B. So part B said if the tricycle section was 4/10 of a mile, what percentage of the total race is it? And we talked about parts of the whole in the previous questions. So we want to know part of the whole, just again going back to percentages and what percentages mean. Percent means what you got out of the total. So if we know that the tricycle is 4/10 of a mile, and that is out of the whole race is 2.5 miles, and we just figured that out in the previous question, letter A. So what is 4/10 out of 2.5 total miles? It would give us 0 and 16/100ths miles. Oh, percent. So 0.16 miles is your decimal. So what percent is that? Well, remember that is 16/100ths, which is 16 out of 100, which is 16%. So that means that the tricycle part of this race is 16% of it, and it is 4/10 of a mile. So there are two different ways to represent this portion of the race. Question C says, estimate what portion of the total race length the 1 mile run will be. So we've already talked about skateboarding, letter A. We talked about tricycle in letter B. So we want to know estimating the portion of the race that the 1 mile run will be. Then find the exact percentage of the race that is the running segment. Does your answer make sense when compared to your estimate? So again, go ahead and pause the video. Use what you guys know about percentages and how to write equations to solve that, and how to set up portions or ratios to see if you guys can estimate and find the exact number of the running part. So if you guys see up here, letter C, so we're still looking at the equation that the skateboarding plus the tricycle plus the running gives us 2.5 miles total. We know that the running is 1 mile out of the total 2.5 miles. So the part to the whole, so again, thinking back to test, you got 1 point out of 2.5 points, gives you what percent? So 1 divided by 2.5 should give you 40/100ths, and 40/100ths is 40%. All right. So Miss Lanza and I were kind of arguing over here about, initially we thought that it should have been, what, 74. And many of you out there may have got 74 as well. So we're going to explore a little bit about why the answer isn't 74. Because if you think about 1 mile is less than half, or less than 50% of our total. So it should make sense that our decimal or our percent is less than 50% as well. So let's see in the next couple of questions why that is. So letter D says, work with your team to draw a diagram representing the entire race. Place each of the events on the diagram. Do your results for the percentages still make sense? So go ahead and draw a diagram.
All right, so I made a diagram, and then we knew that the skateboarding was 10% of the race, the tricycle was 16%, and the run was 40%. But when you add it up, we know that the percents have to be out of 100. So when you add 10 plus 16 plus 40, we only get 66%.
But how can that be? If our entire race is skateboarding, tricycling, and running, that is the whole race. That's 100% of the race. So how is it that we get only 66%? Did we make a mistake? So if you go back now, letter E says, oh wait, said Ruby. Ruby forgot that there's actually a scooter portion of the race too. All right, so if we go back and now add the scooter, okay, we can go ahead and determine what percent of the race that should be. So if we know that 40 plus 16 plus 10 is 66%, we know that 34% of our race must be the scooter. So question E says, using that information now, how long is this scooter portion of the race? So what is 34% of the total? So 34% as a decimal of our total, we know our total is 2.5 miles. So what is 34% or 34 hundredths of, sorry, so again, 34% of our total is what amount, Ms. Lanzo?
85 hundredths of a mile.
85 hundredths of a mile. So now we know the percentage and the distance of our skateboarding, tricycling, running, and scooter portion of this race. So this was a really detailed problem. There's a lot of really good, useful information in here. So again, if you guys are having trouble, if we moved a little bit too quick, I really encourage you guys to pause, rewind, rewatch portions of this question if you need help. So this question had us doing the same process several different times. So last question for today, 43. The Iditarod dog sled races run each year in Alaska from Anchorage to Nome. At every rest stop throughout the race, a veterinarian checks each team of dogs. Copy and complete the table that represents one team's rest stops. So go ahead and pause the video, copy this table, and complete it into your notes.
All right, so this is similar to the T-charts we've been making throughout the last couple chapters. So we have our sections, our distance in miles, and our percents. So one of the things we know is C. We have 220 miles, which equals 20%. So we went ahead and found out how much 1% would be. So if you divided 20 by 20, you'd get 1%, and 220 miles by 20, which gives you 11 miles. So now we have our rule, or our unit rate, to help us solve the rest of the missing pieces. So we know our rule going this way would be to divide, and going this way to multiply.
And what are we dividing and multiplying by there? By 11. So 20% divided by, 20%, 20 times 11 gives you 220. And 220 divided by 11 gives you 20. Okay.
Okay. So if we look at our distance for section A, it gives us 176. So we know we're going this way to get the percent, so we have to divide by 11, which is going to give you 16%.
So B is the same idea. So if we have a distance of 231 and we already know the rule is to divide by 11, we're going to get 21%. And that's the same for letter D then, right? 308 divided by 11.
28%.
So those all follow the kind of the same rule, that last one where they give you the percent. So 15%, how are we going to go the opposite way to get to the distance then?
We're going to multiply by 11. So 15 times 11 is going to give you 165 miles.
So we know that the Iditarod, this sled race, the entire race has to be a whole, it has to be 100%. So if we add up those percentages, we should get 100%. And you may not want to take our word for it, add them up and see if you get 100%. So we know 100% of the race is all those sections, A, B, C, D, and E. So if we add up all of our distances there, we get
1,100 miles.
So 100% of our race is 1,100 miles.
Could we also have taken 100 and multiplied it by 11 to get our total?
Well, if it follows that rule, that rule should apply throughout this entire problem. So is 100 times 11, 1100, and is 1100 divided by 11, 100? And the answer should be yes, it is. So when we talked about unit rate in the last chapter, this is a really practical example of how you can use that in numerous different situations. All right, great job today, guys. That's it for today. Please work hard on your homework. Make sure to spend the time tomorrow going over the video, watching the homework review, and making corrections as need be. All right, we'll see you guys tomorrow.